going?
Good.
Good. So about 20% of the class did not turn in their lab reports. So despite myself, I've opened up the lab again. So it will slam shut at 4 p.m. So please upload your lab report, because if you did the work, I want you to get a grade for it. Okay? But I got to have a cutoff date. So if I don't get it by 4, then it's going to be a 0. So upload that if you haven't already. So any issues with lab 2?
No, it's just I just want to make sure that I'm doing the diagram right. So can it be just like a schematic?
Yeah.
Okay.
Yeah. Yeah, just something so that someone reasonable can look at it and know what was connected to what.
Okay.
That's all.
Question.
Yeah.
Is there a maximum number of arguments that a print statement can handle?
Not effectively. I mean, if you wrote something that made 1 billion statements, 1 billion %Ds or something, it might blow up, but under reasonable terms, not that I know of. But it can get harder and harder to get the counts right. And you can always print without a new line at the end and break it up into multiple prints. All right, well, let's talk about Lab 3 then. So Lab 3 I posted last night, and you got 2 weeks to do this one too. Lab 2 was output. We were lighting up LEDs from a bash script. Lab 3 is input. We're going to read switches into variables in our bash script and then do things with them. So I brought my own version.
On lab 3, it says lab 2 can be found here.
It says what?
On lab
Oh.
3, it says lab 2 can be found here.
Yeah, that's a bummer. Let me see if I can fix that quickly. Thank you. All right, Lab 3 can be found here. Thanks for catching that. All right, so let me show you the basic setup. So first thing, Lab 3, you're going to be using switches. Our switches look electrically like the switches from 250, 270, 120, right? They either make contact or they don't make contact. So in technical terms, we call these single pole, single throw. And instead of using those dip switches with the little sliders or rockers, we have push buttons here. So you push the button and it makes contact, you release the button and it breaks contact. Okay, and these are a little more fun to work with than the little dip switches that you have to get your pencil in and stuff. So there's 2 tricks to using these switches. The first trick is that they have 4 legs on them, and you're going to have to figure out what those 4 legs do. But basically, when you press the switch, this side gets connected to that side. And these 2 points are electrically the same. It's just giving you options. But before you write code and start Googling and all this kind of stuff, grab your switches, grab a multimeter, make sure you understand how the switch works. Okay? Figure out which pins are normally disconnected, but that if you press the button down, the pins are connected. So that's your first challenge. The second challenge is, and it's hard to see, but these legs coming off of the switch, so there's 4 legs coming off. They have like this wrinkle to them. Maybe it's 2 wrinkles, I don't remember. And it makes it hard to put in the proto board. So get yourself a pair of like needle nose pliers, or find a hard surface and use your thumbnail or something and try to straighten these legs so that they go in your proto board. Okay?
Do they have those?
Say what?
do you think, Alphonse?
Because if you have a printed circuit board with a hole in it, and you push this in, this goes through the hole, it kind of snaps in, and then if you turn the board upside down, it won't fall out. But for a proto board, it's just kind of inconvenient. So your hardest part of building this circuit is going to be getting the switches into the proto board. Okay, once you've done that, the circuit's pretty straightforward. So I think they go like this. And the way I've got them right now, these two sides get connected or disconnected. All right, let me log in. So we used the GPIO mode command last week to set, or 2 weeks ago, to set these things up as outputs, and then we said GPIO write, port number value to write a value. Similar pair of commands for doing input. So the first command is GPIO mode number in, and then GPIO read number. So for example, if I say GPIO mode 4 in, that sets up pin 4 to be an input port. Okay, pin 4, you got to go to that table from lab 2 of the GPIOs, but it's the same ports we were using last time, GPIO 4, GPIO 5. And it's pin 16 and 18, then pin 20 is ground. So I'm going to,
Same pins?
say what?
Are you using the same pins?
Same pins.
Okay.
So this blue wire is GPIO port 4, this black wire is ground. Okay, so this pin 16, that's 18, that's 20. So I'm going to do these commands here, GPIO mode 4 input, then I'm going to say GPIO read 4, and it's going to read a 0. And it's reading a 0 because this isn't connected to anything, there's no voltage coming into it, right? And if I connect this to ground, it's also going to read a 0 because ground is 0 volts. So we've got this problem where if we just take a switch and we send this into a circuit, the circuit mostly sees a 0. So in 120, 250, 270, how do we wire up switches to be able to send in a 1 or a 0? Do you remember? Say again?
You make it so when you close the switch, it goes.
Make it so when you close the switch, it goes to ground. And then you got to do one more thing.
Like a resistor.
Say again?
Do like a resistor.
Need a resistor. Okay, so we put a resistor here on the input. Go up to positive 5 volts. 1 k ohm resistor. So this is called a pull-up resistor. And we do this in pretty much every lab anytime we want to use a switch. And the logic is, if the switch is disconnected, this is pulled up to a logic 1 because it goes through a resistor to 5 volts. If the switch gets closed, this gets connected directly to ground, that's a logic 0. And your 1K resistor drains 5 milliamps, pulls the 5 volts down to a 0. Right? So now we can press the button, see a 0, release the button, see a 1. But I said that we don't ever want to connect 5 volts anywhere in our circuits with our Raspberry Pis. So we're not going to build this. Here's the cool part. We can set it up so that the Raspberry Pi actually builds this part of our circuit for us. Okay, we can ask it to actually create a resistor connection between an input port and 5 volts. And we do that with the mode command. So instead of saying GPIO mode 4 in, we're going to say GPIO mode 4 up. And up is short for pull up. So it says GPIO port 4 is an input, but we also want this 1K pull up resistor so that if we don't connect anything to this pin, it reads as a logic 1. If we connect to ground, it'll read as a logic 0. So we're going to do that up command. And now if I read from GPIO port 4, it tells me it's a logic 1. And every time I read, it's going to see a logic 1. But now if I take that port and I connect it to ground by just touching those wires together, it reads a 0. So I can tell if my wires are connected or disconnected. Okay, so that's our basic input mechanism. So GPIO mode 4 up, and then GPIO read 4, and it outputs a 0 or a 1. And you can do the same thing for port 5. Okay, so there's a recap of it. Basically, GPIO mode, port number up, GPIO read, and connect that port number to ground if you wanted to send in a 0. Otherwise, it'll be a 1. Okay, so next issue is that these GPIO commands are displaying something on standard out. We'd like to put those values into a bash variable so we can put them in if statements and so on. How do we do that? I'd like a bash variable that's equal to 1 if my input is grounded, if my input is open, and equal to 0 if my input is grounded. And we touched on this really briefly. So the trick is to use these back quotes. So remember, if you put a bash command in back quotes, it executes the command, but whatever output that command generates becomes the value of this back quoted expression. So in this statement, pin 4 equals, and pin 4 will be set to whatever this GPIO command displays. So I can say pin 4 equals back quote GPIO read 4 end back quote. And now if I echo pin 4, it's equal to a 1. If I short my input to ground and I run that same statement, and now I look at pin 4, it's a 0. And it doesn't matter that these wires are disconnected now because pin 4 is just a variable and it's been set equal to the value when I ran that read command. So if I set it again and I look at pin 4, it's a 1. So that one statement, right, pin 4 equals back quote, lets you figure out what the position of the switch is and store information in a bash variable that tells you the position of the switch. And that's all you need to do to really kind of read from the outside world to do this lab. All right, so wiring the circuit. You should have a pair of switches in your parts box. If you don't, let me know or let Izad know and we'll find you more because we have a big bag of them somewhere. And you're going to want 2 switches, and your circuit is really, really simple, at least compared to most labs you've done. So you have a switch that you're going to think of as up. You have a switch that you're going to think of as down. These get connected to ground, which is pin 20. This goes to pin 16. This goes to pin 18. There's your whole circuit. So even easier than a PIC processor. So let me reconnect my wires here. So what have I got? I've got one of my GPIO ports going to one side of the switch, the other side goes to ground. I copy that ground wire over to one side of this switch, and the other side of that switch goes to my other GPIO. So 2 switches, 4 wires. Like I say, the hardest part is getting the switches inside the protoboard. Once you do that, it's pretty fast. So we can test these switches now. Right, so that's what port 4 is returning. If I press this button, it reads a 0. If I release the button, it reads a 1. If I read port 5, that's reading, oh, I didn't set up port 5. So GPIO mode 5 up. So if I read 5, that's reading a 1. If I push this other button, it reads a 0. Release, it reads a 1. Okay, so that's experiment 1. What we just did, like those past 10 seconds, right? Basically build your circuit with 2 switches, 4 wires, hook them up in this way, type your 2 mode commands, mode 4 up, mode 5 up, and then play around with this GPIO read. Right, so if you read 4, it should give you a 1 if it's released, 0 when you press the button. Do the same thing with port 5. Okay, you don't need to demonstrate experiments 1, 2, or 3 to anybody. Experiment 4 is the one you get sign off on. Okay, so experiment 2, we actually write some bash code. And the basic setup is you're going to have a variable inside your script, you can call it count, initialize it to 0, make an infinite loop that prints out the value of count. Okay, so it just keeps printing out again and again and again. So I call this lab 3. Fine. All right, so it just keeps printing out a 0 because that's the value of my variable count. But inside your loop, put in some logic that reads the value of each switch. And if your first switch is pressed, it should add 1 to count. And if your second switch is pressed, it should subtract 1 from count. Okay, so it's a few lines of bash code. But the effect is, if I press this button, my count goes down. And if I press this other button, my count goes up. And it's always displaying the value of count, just again and again and again. But every time I press, it goes up. And if I press and hold, it'll just keep going up. And if I press the other one and hold, it'll go down, and so on. Make sense? So that's testing. So experiment 1 tests your basic switch setup, your connection to ground, your connection to your ports, and your ability to use the GPIO commands. Experiment 2 just builds on that and puts all of that in a loop so that you can see pretty painlessly if your switches are doing the right thing and if your code is responding to them. All right, experiment 3 is just like experiment 2, but we only want to display the count when it changes. So over here, well, let me just run this again. Right, I'm repeatedly showing the zeros. Experiment 3, I just want to show that 0 once. And then when I hit this button and the count goes up to 3, I just want to see that number 3 once. Okay, so what does that look like? There's a 0. When I hit this button, it counts up. When I hit this button, it counts down. But when I'm not pressing a button, it doesn't keep displaying that last number over and over again. It's just showing when things change. So how do we do that? And you've actually done this a few times if you've taken 270. So in your first, well, definitely in your adder lab in 270, you only displayed the value. You only sent the value to the output port if it changed. I don't know if you remember that. So the idea here is we're only going to display that count if it's different from what we just displayed the last time. So how do we wire that up in code?
Compare it to the last number, and if it's the same, then don't print it.
Compare it to the last number, and if it's the same, don't print it. So let's just say count equals last question mark. And if yes, then we're just going to come down here. But if not, then we're going to display count. And then we got to do one more thing if we're on this branch. Before we adjust count, say again?
The update count?
Before we update count, update last, right? So last equals count. Because if we don't do this, the next time through, count is still going to be different from last. We're going to display it again. So this is one of these places where I would put a comment in my program, probably in big letters, saying last is always the last number we printed, or something to that effect. Because that helps me understand the meaning of this variable, right? my intent is that last is always the last number we displayed. So if the current count is different from the last number we displayed, we have to display the current count. Right? That tells me this makes sense. And if we just displayed this, I better update last, because last is always supposed to be the last thing we displayed. So I'm going to set last equal to count. Right? And that keeps everything kind of running. Okay, and then the usual stuff. Is the up button pressed? And if it is, then increment count. And then is the down button pressed? And if it is, decrement count. Now we just kind of go back to the top. So you got some initialization in the beginning, which is just basically those two GPIO mode commands. And then that's your main loop. And there's other ways you can do this. But basically, if the up button is pressed, increment. If the down button is pressed, decrement. And display if the number we saw last is different from count. And so that gets you experiment 3's behavior. And then you go on to experiment 4. Experiment 4 is the one you're going to demo. Well, it's exactly the same as experiment 3, except that when I press this button, it doesn't just count by 1, it counts by 5, or maybe by 4 if I'm very fast. But it's very hard to get it to count by exactly 1, unless you like have the touch. So experiment 4, we want to debounce this switch, and debouncing is very easy. Just throw in a sleep statement after the display. So sleep 0.25 will wait for 1/4 of a second. And put that in right after the display, and you should have debouncing. So you're going to add one statement in here. Something like sleep. 1/4 of a second. So that's lab 3C. And this one works pretty well. So you can count up one at a time, you can count down one at a time. If you press both buttons, nothing happens because you're incrementing and decrementing count, and it says, well, the value hasn't changed. And if you hold a button down, it will count up every 1/4 of a second. So it's got the auto repeat feature, you can charge extra for that. All right, so that's experiment 4. That's the one that you're heading towards. And my version with comments is like 39 lines of bash, but you can probably do it in half that if you must. All right, so what do you want for your sign-off? 3 things you want to demonstrate to whoever's witnessing. 1, if you're not pressing any buttons, it's not printing out 0, 0, 0, 0, 0. It showed you 0 once, and it's just kind of sitting there, okay? If you press the up button, your count should increment and it should display that once. And if you press the down button, it should decrement and display that once. All right, do those 3 things, you get signatures, put it in your lab, you're good to go. Does that make sense? All right. That's all there is for lab 3. All right, so same thing as last time, individual lab reports. You can share circuit diagrams, and you can share source code listings and the signature sheet with the witnesses. And then everything else should be your own words. All right, so questions on anything up to here? high-low or ODPs, ODP 414.
What kind of things are going to be on the radar? Is it going to be like this programming task?
Computer science-y things. Mostly short code segments that I'm going to ask you to write. So ODPs, programming assignments, good practice. Unix, there may be some more sort of conceptual questions, but we'll go through a study sheet next week and talk about probable topics. But probably, you know, at least 3/4 of it is going to be writing pieces of code. But probably not complete programs. Okay, I won't say, you know, write an operating system. I might say write a function that takes an array of integers and returns the sum, right? Which I think was an ODP, or will be an ODP. So that was my version of ODP 414, right? And I think this is similar to what most people did. The main thing is we have a pair of pointers in here. We have in location and out location. And they're not always the same value. If we're copying from one string to another, we can just use one index I, right? And output I equals input I. But here we're building an output string that's longer than either input string. So I have two pointers. Out location is where we're writing into this output string. In location is where we're reading from one of the inputs. And out location basically increments twice through. And I also use it to put a null terminator at the end of the for loop. But as I mentioned yesterday, this is totally typical of what you see when you do string processing. Right, you need sometimes a pair of pointers, one for input, one for output, and they might do totally different things, right? And if you have separate pointers, relatively straightforward to keep them separate. To keep them clear what they're doing. All right, so we have about 15, 20 minutes. I don't want to start something brand new right now. So I'm going to use this as one of several opportunities this quarter to talk about VI. And I don't require you to use VI, although I encourage it. I'm not going to test you on VI commands. But it's a useful environment for editing if you're comfortable with it. And since most people use VI in 121 and leverage over to using VI in here, I just want to kind of like introduce some of the things that you can do in VI that you may or may not be aware of or be fluent in. And the goal is not to give you a list of 20 commands and you got to memorize these for some reason because we went over them in class, right? The goal is just to sort of like introduce you to some of the things you can do so that if you're editing and you're doing things the way that you've done them before and it's always kind of seemed like a pain and you remember, hey, we saw something on Friday that was a whole lot easier than this, right? Then maybe you go look it up in your notes and you try it. And if it's kind of cool, you stick it on a little Post-it note and put it somewhere. And the next time you have to do the same thing, you look at your Post-it note, and if it saves you time, right, or it hits your brain in a good way, you'll remember it. And if you don't use it, you won't remember it, and it doesn't matter, right? So these are some of the things that I do in VI that you've probably seen me do up here that I think are useful under different circumstances. Like I say, you're not required to memorize these, you're not required to use these, but my goal is always to try to be efficient and to not be distracted. And most editors distract me. VI distracted me when I was learning it, but it got me somewhere where I wasn't distracted. So the first thing is is moving around. So generally people use arrow keys to move around their file. And if I'm in insert mode and I use my arrow keys, weird things happen, right? So I gave you a way to fix that in your setup. But not all VI setups understand arrow keys. So the usual way to move around in VI is with H, J, K, and L. So H is backspace, J is new line, K is previous line, L is to the right. I don't actually use the L key usually because you can also get there with a space bar. And that'll move you to the right. So J goes down, space goes over, K goes up, H goes back. And those don't work in insert mode, but I never was bothered by that until I saw people using arrow keys. So we can move around like that. But arrow keys or space bars take a while to get where you're going, right? So sometimes I want to get over to that word starting, right? So the W key moves you over one word at a time. So that's a little more efficient. So W says move over one word. And words in VI are usually things delimited by things other than letters. So for example, W got me to the beginning of don't, another W gets me to the apostrophe, another W gets me to the T, jumps over to the P, and so on. And a lowercase b moves backwards one word at a time. If you want to get to the end of a line, you can hit a $sign. And $sign almost always means the end for some reason.
Press E at the end of a word.
Yes. You can press E to get to the end of a word. Right? Or W to get to the beginning of a word. And you can hit a 0 to go to the beginning of a line. So if you're in here and you want to change the word history, I can just hit a $sign to get to the end and then go back to the beginning of history. Or I can hit a $sign and then just hit a B to jump back to the beginning of that word. Right? Does this change your life in a fundamental way? No. But it's a whole lot faster to me than doing this. And it's not that this takes time, it's that it takes attention. Right? I have to watch where it's going. And if I go too far, then I got to back up. And now I'm playing a video game with my computer. And I think this is partially from like days when we worked on dial-ups, and you might hit the space key 5 times and nothing happens, and then all of a sudden it jumps across 5 characters. And you're constantly like coming up with these algorithms in your head for how to most efficiently, right, be able to get there without having to actually wait. So those are shortcuts, $sign and 0 to jump you to one end or the other. Okay, so that's movement on a line. If you want to move down, you can do a J and move down, or a down arrow. You can also say Control D and jump down half a page. And Control U will jump up half a page. Control F will go forward a whole page at a time. Control B goes back a page at a time. So those get you to different parts of your code. I don't actually use Control F and Control B. I learned them, but I never use them, so I don't know why I even put them on there. But Control down, Control up is how I mostly move around a file. And yeah, you have to wait for auto repeat to kick in, but once it does, it's a pretty fast way to get through a file. But you can also say number with an uppercase G, and that says go to that line number. So you compile your program and it says, you know, syntax error, line 38, come into VI, 38, shift G, and I'm at line 38 in my file. And if you hit Control G, it will give you information about where you are. So this shows line info. So it says I'm at line 38. If I want to get to the first line of a file, I can just do 1 shift G, because I know the first line is line 1. I don't know what the last line of my file is, but if you just hit a shift G without a number, that takes you to the last line.
Your editor is annoying.
Yeah, I know. I'm just writing what I just said. So number G goes to line number, G goes to the last line, and Control G gives you line info. All right, so moving around the file, right? Lots of ways to do that a little more efficiently. What about editing? So, CW is the change word command. So let's say I want to let's say I want to change the word anything, right? So I can hit a $sign to go to the end of the line. I can hit a B to go back, and I can say CW, and that says I want to change the current word. So it shows me a $sign where the word ends, and it puts me into insert mode. And now I can, you know, type a word, hit escape to come out of insert mode, and I've changed it to say don't do nothing. Here I can say CW and change that to output, and I can change starting to beginning, and so on. Right, and that's a fair amount faster than going to the word, moving to the end, going to insert mode, hitting the backspace a bunch of times, and then typing in your new word. Right, 2 characters CW, you're in insert mode, type in your text, and you're done. And I think this is why the arrow keys never occurred to me as being an issue, because most of the time I'm living outside of insert mode, right? Because mostly I want to look at my file and I want to move around my file. And when I'm typing things into my file, that's when I'm in insert mode. But as soon as I'm done typing something in, I just hit an escape, and now I'm back in this sort of command mode. Where you can do things like move around with W's or Control D's and so on. Okay, so CW changes a word. If you want to delete a word, that's DW. So I don't like some of these words in here, so I can just hit DW, get rid of the, DW gets rid of window, DW gets rid of size, and so on. I can hit an uppercase D, which says delete, to the end of the line. So I don't want any of this stuff in here. I just hit a shift D, gets rid of all the trailing stuff. All right, DD, lowercase, deletes an entire line. Shift D deletes from my current position to the end of the line. DD just gets rid of the whole line. It doesn't matter where I am in that line. I can be sitting halfway through it, If I say DD, it takes out the whole line. You have at least one level of undo. So if I hit a U, it will undo whatever I did last. I just deleted a whole line. If I hit a U, it undoes that deletion. If I hit a U again, it undoes my undo, which basically redoes my deletion. And I can just lean on my U, and all it's doing is undoing my last line. If I do a Shift D to remove the end of that line, right, I can hit a U to undo that. Right. If you make a bunch of changes on a line and you hit a U, it'll just undo the previous change, and then it'll redo it. But if you hit a Shift U, it'll undo all the changes you made on that line. So Shift U brings you back to where you started, but it only works on that current line. So undo last action. A big U says undo all on current line. But that's kind of limited, right? So I make a bunch of changes on here, and I make a bunch of changes on here. If I hit a Shift U, it undoes everything that I did on the current line, which is this. If I go up here, I haven't made any changes on this line yet, right? Since it became my current line. So if I do a Shift U, it's still undoing, right, what I did down there. So it's not a silver bullet, but most installations of VI have multiple levels of undo. So if you hit U, it'll actually take you back. All right, so one of the coolest things you can do in VI is a period. And a period basically says repeat last action. So let's go up here and let's say delete word, DW. Okay, if I hit a period again, it will repeat my DW command, which deletes the next word. And now I'm deleting one word at a time just by hitting a period. If I say change word to going, and then I come down here, and I hit a period, it's going to say change this word to going. Right? So if I'm trying to change something multiple places, that's one way to do it. There's better ways. All right, there's also a paste buffer. So let's come up here to the first line over here. So I don't know, let's find some. So here's this hist control, say DD, which deletes that. Okay, it's gone from my file, but it copied that into a temporary location, a paste buffer. And maybe I'll Shift G to the bottom of the file, and I want to put that line that I just deleted right down here. I can just hit the letter P for paste, and it'll paste it in there. So P is your paste. And your paste buffer can be pretty big. So maybe I want to take these top 5 lines. I'm going to say 5DD to delete all 5 of them. Come down here and paste them.
Looks like it maxes out like 51 lines. Included 51.
I don't think so. So I can delete 200 and then paste them in down here. So there shouldn't be a practical limit.
Between different files.
Possibly.
Like remember that they run between the two,
Yeah.
AM2, they're trying to transfer stuff around.
Huh. Interesting. If you run into that again, let me know what you're doing, because I've never seen that. But yeah, that's totally plausible.
But it might be because we have between separate files and directories.
Mm-hmm. Could be. All right, so I snuck something in here on you also, which was if you type a number followed by a command, that says do your command that many times. So if I say 5DW, that does my delete W 5 times. Gets rid of 5 words. If I want to get rid of this case statement, which is 1, 2, 3, 4, 5 lines, I can say 5DD, and my case statement is gone. If I want to put it back, I can go up and hit a P, and it pastes it back in. If I want to duplicate it somewhere else, I could come down here and hit a P, and it'll paste it in right there. If I want a whole file of case statements, I can just lean on P, and now I got a whole bunch of case statements. Two others that are pretty useful, little o and big O. So this is called open. It opens a new line either below or above your current line. So you're in your file and you want to add something right at the end of this, a new line below this. Doesn't matter where you are in the statement. If you hit a lowercase o, it creates a new empty line, puts you into insert mode, and you can start typing. And if I want to put something before my first line, I can hit an uppercase O. Same thing, but it opens a line before the current line, puts me into insert mode, lets me start typing. And you start to pick up little habits, right? If I want to swap the order of these first 2 lines, in my brain it's just DDP. DD deletes this, and then P pastes it, and that swaps the order of those 2. I completely forgot to mention X. X is a useful one. X deletes a single character. So if I want to get rid of this dash, I can just hit an X, and it's gone. And I can hit multiple X's. If I want to get rid of 10 characters, I can say 10X, and it gets rid of those 10 characters. And if I want to paste what I just deleted, I can just hit a P, and it'll paste it right there. So like I say, don't have to memorize these. You don't have to believe in them, right? But as you're editing, if you're constantly in the situation where you want to insert a new line and you have to arrow key over to the end of the line and then go into insert mode and then add a space and back up and go over and say, or something like that, right? And do you remember, wait, we saw something in class to do that, right? Look at your notes. Oh, just hit an O and it opens. Give it a try, right? If you like it, make a note of it, use it some more, and you'll develop your own sort of subset. And this is a tiny, tiny, tiny subset of VI, right? But this is mostly what I've done for like 40 years in Unix is these commands. So you'll find your own subset. We'll talk a lot more about VI down the road. I want to talk about searching when we get to regular expressions. We'll come back to VI and play around with that. Anybody here play Rogue? So Rogue exists on the Linux server. You're welcome to play it. But that's a good HJKL practice because you can use those to move around the dungeon. So. Say what? What controls? What do you mean? In VI? Suggestion would be download a cheat sheet because it's kind of hard to tell by just trying things. But if you want to know something other than what's on here, there's a ton of cheat sheets available, just like one-page cards that'll summarize commands.